Welcome back. Problem 11-30. So statement is the simply supported beam support a load of 16 kilonewton. Determine the smallest dimension A of each timber if allowable bending stress for the wood is 30 megapascal and allowable shearing stress is 800 kilopascal. Also, if bolt can sustain a shear of 2.5 kilonewton, determine the spacing S of the bolt at the calculated dimension of FMAA. So you can see this is a simply supported beam that is made up of 2A by A timber woods, and they are nailed together. The distance between the nail is S. You can check it. There is a point load at the mid of the beam, that is P, which is given as 16 kilonewton. So first you have to determine the dimension of each timber and then this spacing S. So let's start with the solution. So basically we know that maximum bending stress is equal to maximum bending moment into C divided by I. Clear? So we do not know this I, we do not know C, we do not know maximum bending moment. So what we will do is that if you draw the free body diagram of this beam, so let me draw it like this. If this is the beam, clear, and there is a point load at the mid which is represented as P, clear. So definitely here there will be reaction force. Let this is your R1, this is your point 1, and here this is the reaction which is represented as R2, and this is point 2. This is your point 1 and this is your point 2. So we will find this R1 and R2 by using equilibrium condition. You can check here, this distance is 3 meter and this distance is also 3 meter. So what will be the equilibrium condition? The first equilibrium condition is a set sum of all moment about point 1 is equal to 0 and taking the counterclockwise moment as positive. So P into perpendicular distance 3 and that is producing clockwise, so it will be negative, plus R2 into perpendicular distance is 6 meter and it is producing counterclockwise, so it will be positive. Both moment sum will be equal to 0. So I will write P into 3, that is negative, plus R2 into 3, that will be equal to 0. R2 into 6, sorry, because this distance, total distance is 6 meter. So when you solve this, you will get 3P is equal to 6R2. You are interested to find R2, so R2 is equal to 3 into P divided by 6. Now you know that P is 16 kilonewton. So 3 into 16 divided by 6 will be equal to R2 and R2 will be equal to 8 kilonewton. Now you can find R1 by using another equilibrium condition, that sum of all forces along y direction must be equal to 0 and force upward taken is positive. So R1 plus R2 is equal to P, and P is equal to 16. So from here R1 will be equal to 16 minus 8 and it will be again equal to 8 kilonewton. Now you have both R1 and R2. You can draw the shear force and bending moment diagram in order to get this maximum bending moment. So I will draw a vertical line from each side of the beam, and there is horizontal line to show the length of beam in meter. So this is 3 meter. Now at point 1 you can see you have R1. So R1 is 8 kilonewton. So let each division is 4 kilonewton. So 4 and this will be 8. Similarly minus 4 and minus 8. So here we will draw shear force in kilonewton. So at first point you have R1 which is 8, so first point will be this one. Now you can see from moving from R1 till point B there is no other force, so it will remain same at this point. Now at this point you have P which is 16 minus 16, so 8 minus 16 will bring down it to minus 8. So shear force at this point will be changed to minus 8. And from this point till again end there is no other force, so it will remain same. And at end you have R2 which is equal to 8 plus 8, so it will bring you to the 0. So this is your shear force diagram. Now we will draw the bending moment diagram. So again you have to draw horizontal line. This horizontal line will show you the length in meter, and if you take this as 10, 20, similarly 30, and here you will draw the moment kilonewton into meter. So first area under the shear force diagram is this one. So this area is equal to 8 into 3 which is equal to 24. So at this point we will having 24. So I will plot this point, let this is 24. Now you can see that shear force is a horizontal line with 0 degrees, so bending moment will be 1 degree higher and it will be a straight line. So we will join these 2 points. This is your 24 kilonewton into meter. Now the second area is this one, and this area is minus 8 into 3 is equal to minus 24. So moment at this point will be equal to 24 minus 24 is equal to 0. So as this line is horizontal and this area is negative, so shear force will be 1 degree higher and slope will be decreasing. So we will get this line. Now this is the bending moment diagram. So from this bending moment diagram you can see that absolute maximum value of bending moment comes out to be 24 kilonewton into meter. Also the cross section you can see over here, if I draw it like this, so this is the cross section of this beam. Let this total height is, this height is A, and this is also A. Similarly you have this dimension is A. Clear? And the centroidal axis will be at a distance of A. So it means that your C will be equal to A. Now what about I? So we will calculate I, and we know that I is equal to 1 over 12 BH cube. So 1 over 12, B is A and H is 2A. Total height is H, which is equal to 2A, A plus A. So 2A cube. So this will be I. Now if you calculate this I will comes out to be 0.6667A4. Okay. Now you have all the values. You can just go and you can check the maximum bending stress is equal to maximum bending moment into C divided by I. So maximum bending moment is 24 kilonewton, so 24 into 10 raised to power 3. C is equal to A, so multiply by A divided by I, which is 0.667 A4. And this maximum bending stress or allowable bending stress is given as 30 megapascal. So 30 into 10 raised to power 6. So you can see that this is the allowable bending stress, or maximum bending stress is this. So I will write 30 into 10 raised to power 6 is equal to 24 into 10 raised to power 3A divided by 0.6667 A4. So again, if you take it 0.6667 A4 is equal to 24 into 10 raised to power 3 multiplied by A divided by 30 into 10 raised to power 6. So we will be left with A cube is equal to 24 into 10 raised to power 3 divided by 30 into 10 raised to power 6 multiplied by 0.6667. So by taking the cubic under root, you will get 24 into 10 raised to power 3 divided by 30 into 10 raised to power 6 multiplied by 0.6667. So when you calculate it, you will get the value of A comes out to be 0.106266 meter, or in millimeter A will be equal to 106.2 or 106 millimeter. So we have find out that this A should be equal to 106, but we will check it, cross check it with shear force. So check shear whether it satisfy the shearing stress or not. So we know that shearing stress, maximum shearing stress is equal to V into Q divided by I into T. So V is the shear force, which maximum shear force, which is 8. I is there. T is also again equal to A. So we do not know Q. So we will find Q. So we know that Q is equal to Y bar into A. Now what if I draw the diagram like this? So this is the centroidal axis, this is A, this is also A, and this is A. So we will find the shear first moment of inertia of this shaded portion. So you can see that its Y bar is equal to A divided by 2, and this area is A square. So I will write it Y dash is equal to A by 2 and area is A into A. That will be equal to Q. So this will be equal to 0.5 A cube. Now you have this Q, you can put it in this formula. So what we will do is that maximum shearing stress is equal to V. V is 8 kilonewton. So 8 into 10 raised to power 3. Q is 0.5 times Q is 0.5 times A cube divided by I. I is equal to 0.66667 A power 4 into T. T is also A. So what we will do is that you can see that this is you can put the value of A. So 8 into 10 raised to power 3. This cube will cut with this and we will left here A. Okay, A. So into 0.5 divided by 0.66667 into A square is Tom X. And that is equal to 8 into 10 raised to power 3 into 0.5 divided by 0.667 into A. A is given as 106. So I will take it in meter. It will be 106 whole square. So when you solve this, you will get maximum shearing stress comes out to be 531 kilopascal. And you can see that this is this maximum shearing stress is less than allowable shearing stress, which is given in question is 800 kilopascal. I will show you. You can see this is allowable shearing stress. So it means that this A is equal to 106 millimeter is fine. This is the value of A of timber beam. Now we will move towards second part, and in second part we have been asked that the shear flow So horizontal shear Fs is given as 2.5 kilonewton. So you have to find this spacing. So we know that mm, shear flow, which is given by shear flow means the shear stress per unit length is equal to shear flow, which is equal to V into Q divided by I. Clear? So you have V 8 into 10 to the power 3 and Q is 0.5 times A cube, and A is 0.106 whole cube divided by I is 0.667 A4. So again 0.106 power 4. So when you solve this, you will get this shear flow comes out to be 56462.16 Newton per meter. Now you have this shear flow, so you can calculate this spacing, because we know that shear flow is also equal to horizontal shear into the spacing. So from here, this spacing S will be equal to Q divided by Fs. Shear flow Q per unit length is not, it will be, let me correct it, it is Fs over S, horizontal shear force per unit length. So this S will be equal to Fs over Q. So Fs is 22.5 kilonewton, so 2.5 into 10 to the power 3 divided by Q is 56462.16. So when you solve this, you will get this spacing comes out to be 44.3 millimeter. And this is the spacing between the nails. And that was all about problem 11-30. I hope you have enjoyed this video and you are learning from my videos as well. Those who are new to my channel, then subscribe it and hit the bell icon so that you can get notification about my latest video. If you have any question, you can ask me in comment section. Thank you for watching.